Hi everyone, good morning. Thank you very much for your time and we welcome you to the Architects webinar that is Achieving Zero Energy Building Renewable Energy Targets for New Buildings with BIPV. I am Karthik and I am Assistant Manager in AGC Asia Pacific. I am working in AGC for the past 6 years and I am providing solutions to the customers in terms of technical support for all smart glass products like Glassylate, Helio, Atoch and SunNivat BIPV. In this presentation, I will be focusing more on SunNivat BIPV. I will be sharing my knowledge and the latest BIPV solutions available from AGC to achieve DBKL's 30% renewable energy requirements with case studies through energy generating facades without compromise on the aesthetics. So, if you are interested in our smart glass products, please visit our online exhibition stand by clicking on the button below. A short introduction about AGC. AGC is one of the world's largest producer of the float glass. We are into architectural and automotive glass. We started the BIPV business in the year 2000 in Japan. So far, we have completed more than 400 projects worldwide. We have more than 55,000 employees globally, and our regional headquarters is based in Singapore. So topics for today, renewable energy requirements in the KL Malaysia, then case study examples of BIPV in a zero energy building project, case study by each BIPV types, then summary of the BIPV application ideas, and BIPV in reality, key takeaways, and followed by Q&A. So let me dive into the first topic, that is the renewable energy requirement in KL. As many of you are aware of the KL Climate Action Plan 2050 and highlighted by Datuk Seri Haji Mahadi, we have to take some actions to comply with the Climate Action Plan. In this document, we can also find the total energy consumption that is of the whole Malaysia, 41 percentage comes from the building energy consumption. So that is quite huge, more almost like 41 percentage. So the main key targets that is mentioned in this climate action plan, and the four pillars are the emission neutrals and governance and collaboration. The third one is inclusivity and the benefits, and the fourth one is resilience to climate hazards. So in order to achieve the climate action plans requirement, that is the carbon neutral by 2050, one of the key strategies mentioned is the carbon reduction with the increase in the BIPV. So in this case study examples, which I will be running through, I will explain to you about our different products and how it will help you to achieve the carbon reduction with the help of BIPV. So this is one of the case study which I am going to explain to you based on a real project in Japan. So this is AGC's Kashima factory. In order to achieve the zero energy building or the net zero energy building targets, the energy saving and the rooftop PV is not sufficient. As you can see here on the left side, we were able to save energy from like a air conditioning system like chillers, then ventilation, lighting, and the hot supply. We were able to save energy up to 50.4 percentage, but with the rooftop PV application on the roof area, we were unable to achieve the zero energy building targets. So that's the reason we try to apply BIPV on the facades to enhance the likelihood or performance to achieve the zero energy building. So in this case, with the rooftop PV and the BIPV on the facades, we were able to generate up to 64.3 percentage of the energy. So in total, we were able to achieve the zero energy building requirements with rooftop PV, BIPV on the facades, and energy saving measures like chillers and other lighting systems. So this is the more information about the rooftop PV and the BIPV, which is being used for the zero energy building. So for the roof area, we were using like 530 square meters of a normal rooftop PV panel with 21.1 percentage module efficiency, and it was able to achieve like 111 kilowatt. And for the facades, which is facing the east, we were using 130 square meters of BIPV, that is with vision stripe. We were able to achieve like 13.4 kilowatt peak. So this is how the project looks like from exterior on a daytime, which is shown on the right top. And then on the bottom right, it is the view of from the exterior of the building during the night time. You cannot see any cells on the facades because the cells are like very thin, so you can directly see the lights. And on the left side you can see the BIPV, which is from inside of the building. From a quite far distance also, you cannot see the solar cells which is applied on the facade. And when it's like a close-up view, as you can see on the bottom left, the two pictures, you can see the cells more obviously. So today I will be covering you about AGC's different range of products. So we have two transparent solutions. The first one is the Vision Square, and the second one is the Vision Stripe. And we are having three opaque solutions. The first one is the Lackability Active, the second is Arclight Active, and the third one is the Stop Ray Active. Apart from uh, BIPV as a material for the facades, it also helps to provide you like more transparency, reduction in the ETTV or OTTV values, energy generation. Then it is a laminated glass, so it acts as safety glass, and it also helps to cut the UV light by 99.9 percentage. With the combination as a double glazed unit, that is an IGU, we were able to achieve the thermal insulation. So I will explain to you about each products in detail in the upcoming slides. So before diving into the each product's case study, let's have a short look on the Malaysia's energy or the solar irradiation study. You can see similar to Singapore, Malaysia is also near to the equator, and the sun path is also similar to Singapore case, as you can see on the top right, the sun path of Malaysia. From the irradiation study, we can clearly see that the roof area has the high potential for the solar irradiation. So rooftop applications like skylights and canopy is one of the good potential where we can harvest more energy, followed by east facade, which has more energy generation, followed by west, north, and the south facades. So this is the order, like roof east, west, north, and south facade, which can have like a more power generation. So for the rooftop PV applications, the area of application will be like a very small compared to the BIPV applications because of the regulations. We need like 1 meter spacing from the edge of the perimeter for maintenance purpose. But in case of BIPV applications, we no need any space for those maintenance. It can be directly applied on the canopies or skylights. So it helps to generate more energy compared to the normal rooftop PV application on the roof area. So these are the assumptions which I am going to share with you during this case study for all the products. So we are assuming like a 25-story building and a 50-story building for this case study with a gross floor area of 1,000 square meter and 20,000, sorry, 10,000 square meter and 20,000 square meter with building energy index of 90 kilowatt hour per square meter per year. Total energy consumption for 25-story building will be like 900,000 kilowatt per year, and for the 50-story building it is assumed like 1.8 million kilowatt hour per year. So based on the 30 percentage renewable energy requirements, the total energy the 25-story building has to generate is 270,000 kilowatt hour per year, and for 50-story building it is like 540,000 kilowatt hour per year. And the right side is a small rendering with the Arclight active panels with the 25 stories building and the roof with canopy or skylights. So the first product, that is the Vision Square. As you can see on the right side, you can see the visible solar cells, which is beautifully integrated with the skylights. You can see the visible solar cells here. So the cells we are using for this, all the products are like high efficient monoperc cells, or bifacial cells. We can customize the position of the cells depending on the requirement of the customer and based on parameters like light transmission and the shading coefficient. You can see on the bottom right, this cells are being highly customized as per the requirement from the architect. The cells are being randomly placed. So the power output for this technology, that is Vision Square, ranges from 55 to 180 watt peak per square meter, and the possible applications are facades, canopies, skylights, and if it is like a window wall or other application is also possible with the Vision Square. And we are glad to introduce one of our ongoing project in Singapore, which is the SIT Punggol campus, which is being recently constructed and it is ongoing. Um, the main target for this building is to achieve the super low energy building. So in order to achieve the super low energy building, for this particular portion, that is for the food court, BIPV is considered. So the requirement for this project is also quite stringent, like the shading coefficient has to be 0.17 and U value has to be 1.3. So we were able to achieve this stringent SC value and U value requirements. The total number of panels for this project is 124 numbers with an area of 400 square meter and system capacity of 57.7 kilowatt peak. So this is a small rendering of how the skylight looks like in the food court. The second project I want to share is another one project which we have completed recently in this year. This is AMGT, which is based in Thailand, and we are using Vision Square. The configuration is 6 plus cell plus 6 millimeter glass. Total number of project is 34 numbers with an area of 58 square meters with a capacity of 6.1 kilowatt peak. So you can see the beautifully integrated solar cells with spacing of like 20 to 30 millimeter between the solar cells, and it is applied on canopy or skylight applications. So let's dive into the case study which I have mentioned earlier. So for this case study, I'm assuming like the total area of the facade application, which will be like each facades will be like 500 square meters. So in order to achieve the DBKL's requirement of 270,000 kilowatt hour, and I am using this as a base case study by applying a sun watt Vision Square only on the spandrel area of the facades. So based on this assumption, with the spandrel area only on the top location and rooftop PV, that is BIPV, with the skylight applications, we were able to achieve only 256,000 kilowatt hour per year, which is less than our target requirement of 270,000 kilowatt hour per year. So let's see how we can achieve the 270,000 kilowatt hour without much change on the aesthetics. So this is one of the possible solution which we would like to highlight. So in the previous case study, I have mentioned like the total area of the east facade is 250 square meters. So here I want to increase the total area of the east facade because the total power generation is quite high in the range of 602 kilowatt hour per kilowatt peak. So with the increase in the total area from 250 to 250 square meters, that is applying the BIPV on the top and the bottom spandrel of the floor, we were able to increase the power output to 306,000 kilowatt hour per year, which is more than like 270,000 kilowatt hour per year. So these are the some of the rendering how the building looks like with Vision Square applied on the east and west facade on the top and bottom spandrels, and with the north and south facade with top only on the top spandrel. And these are the roof applications, that is with the canopy or skylights, how the BIPV looks like. So this is a case study for the 50-storied building. So for the 25-story building, we were able to achieve the required power output with only the east facade with top and bottom spandrel, but with 50-story building, since the overall area increases and the energy consumption increase, we were unable to achieve the total power output with only the east facade. So in this case, I would like to extend the area of application to east and the west facades with top and bottom spandrels as BIPV Sunny Watt Vision Square. So in this case, we were able to achieve a total power output of 609,000 kilowatt hour per year, which is more than our requirement of 540,000 kilowatt hour per year. So the next product is the Vision Stripe. So Vision Stripe is the latest technology which is from AGC. We are using the laser cut high efficiency monoperc cells to achieve the transparency. We can also customize the cell's position in order to achieve the light transmission required. It can be applied on the facades and in skylights or in canopy applications. So this is a short video of how this can be applied. So this is one of our project reference in Japan. BIPV Sunny Watt Vision Square being applied on the facades. As you can see here, it is applied on the top and the bottom vision area, and we can see good view on the outside. So this is another one project reference, which is application with as an IGU unit. So in this project, we are using 5 millimeter low iron glass plus solar cell plus 5 millimeter, then 12 millimeter airspace plus 8 millimeter low E coated glass. So the SC value requirement is 0.378 and the U value is 1.6. And this is how the building looks from the outside during the daytime and in an inside view, and it is like a close-up view. So in the close-up view, we can clearly see the cells. So this product, I did not do any case studies because this product is more for aesthetics rather than for energy generation, because the total power output from this product is slightly less compared to other range of products. So next product is the Stopray Active. Stopray is AGC's low-E coated glass. So in order to have a good color matching of the AGC's low-E coated glass on the vision area with the spandrel glass, AGC come out with Stopray Active, which is having a good color matching of all our different range of Stopray series like Vision 40T, 50T, 60T. The performance of the product is also slightly good in the range of 80 to 85%. That is compared to the Vision Square. And typically we can expect a power output range of 130 to 150 watt peak per square meter. And this is a picture of how the building looks like with the Stopray Active on the spandrel area, which is on the top, and Stopray 40T blue, which is used on the vision area of the facades. So you can see like the reflection is almost similar when we see from the outside, and you can have like a very good color matching, which is one of the key considerations considered by the architect on the color matchings. So this is the case study with 25-storied building. For this case study, it is something similar to the Vision Square area. So in order to achieve the total power output requirement, that is more than 270,000 kilowatt hour per year, we had to apply the Sunny Watt Stopray Active on the top and bottom spandrel areas for the east facade, and for the other facades like north, west, and the south, we can apply the Sunny Watt Stopray Active only on the top spandrel area. So with this whole combination and the Vision Square on the roof area, we were able to achieve a total power output of 283,000 kilowatt hour per year, which is more than 270,000 kilowatt hour requirement. So this is how the rendering looks like. So this is the east facade, and this is the north facade, and the backside will be like a west, and the backside will be like south facades. So here you can see this is the stop reactive, and this is the vision square being applied on the roof area on skylight applications. So this is for the 50-story building application. So it is similar to the vision square. Um, the area of application for the east and west facade has to be increased like top and bottom spandrel for the stop reactive, and for the north and south facade it can be like only top spandrel. And for the roof skylight, similar with the vision square, we were able to achieve a total power output of 554,000 kilowatt hour per year, which is more than our target requirement of 540,000 kilowatt hour per year. So the next product I'm going to explain is the Arclight Active. So Arclight Active is AGC's Arclight is AGC's printed glass. So Arclight Active is AGC's printed glass combined with the solar cells in order to achieve the required aesthetics like a logo or some kind of customized patterns like a brick or some other patterns. It is fully customizable, and we can expect a power output performance of 70 to 90 percentage compared to the vision square, and total power output can range from 100 to 150 watt peak per square meter. And some of the possible applications are cladding, spandrel, and balustrades. So this is one of our project reference in Netherlands, where BIPV is being applied on the facades with logo and other requirements from the Shell corporations, Shell Technology Center. And this is another one project reference which we recently completed in Paris. It's Tours Duo, and BIPV is being applied on the roof area with the colored BIPV. And this is the case study with Arclight Active, how we can achieve the total power output requirement. So for this power output, as you can see here, since the overall power output is slightly less compared to the vision square, we have to increase the overall area of the BIPV applications to the east and west facades with the top and bottom spandrels. And for the north and south facades, we can consider to use only on the um, top spandrel area, and for the roof only on the skylights, the normal one, so that we were able to achieve the total power output requirement of more than 270 kilowatt hour per year. So in this case, we were able to achieve like 289,000 kilowatt hour per year. So then this is the case study with Arclight Active for 50-story building. So for this 50-story building, since the total energy consumption is high, we want to increase the overall area of the application. So for this case, for all the facades like east, west, north, and south, we have to increase to like a top and bottom spandrel has to be with BIPV. Arclight Active, so that we can achieve the total power output requirement. So based on this, all the area like top and bottom spandrel, we were able to achieve a power output of 614,000 kilowatt hour per year, which is more than 540,000 kilowatt hour our requirement. And this is rendering how it looks like with the stop reactive different range of products. So this is with stop reactive purple color patterns, and this one with Arclight Active with green patterns, and the left one with Arclight Active purple patterns. So this is another one rendering with 50-story building with BIPV being applied on the facades, that is with Arclight Active with purple color patterns. So you can slightly see some difference in the rendered image, that is like when a direct sunlight and when it is slightly shaded, how it looks like, as I can see on the left. And we are having like customized patterns like orthogonal, star, and the radial pattern, and the power output can be mm, also can be depending on the different types of patterns like optimal, medium, and basic type. So we are having some standard architectural materials, artworks, nature, and RAL colors to achieve your requirements. And the next product is the Lockability Active. Lockable is AGC's colored glass, and with solar cells integrated with the Lockability glass, we come out with the Lockability Active. We are having 7 standard colors, and the performance can range from 40 to 70 percentage compared to the Vision Square, and the power output also ranges from 100 to 160 watt peak per watt square meter. And these are our standard colors like black, blue, gray zen, and the white mist. And these are some of the project references in Europe with the Lacobel black. And this is a case study. So for the case study, it is similar to the ArcLight Active. Since the power output is slightly less compared to the Vision Square, we have to increase the overall area. So for this case also, we are considering like Lockability Active has to be applied on the facades on top and bottom spandrel so that we can achieve the total power output requirement. For this case study, you are able to achieve a power output of 326,000 kilowatt hour per year, which is more than 270 kilowatt hour. Then this is how the rendering looks like with like a Lockability Active on the facades and on the roof area with Vision Square. And this is a rendering with terracotta color and Lockability blue. And this is for the case study with a 50-story building. So 50-story building also similar to the earlier case study for 25 stories. Lockability Active has to be applied on the top and bottom spandrel in order to achieve the power output. So here we were able to achieve a power output of 566,000 kilowatt hour, which is more than 540,000 kilowatt hour, which is the requirement. And this is a summary of the case studies for 25 stories. So with the Vision Square, we were able to achieve the power output requirement with 2,871 square meters. And for Stop Ray Active also, we were able to achieve with 2,871 square meters. But with ArcLight Active and Lockability Active, we have to increase the area like 3,300 and 4,300 square meters in order to achieve the total power output. So the total power output depends on the product which we are going to select, like whether it's a Stop Ray Active or ArcLight Active or Lockability Active. And this is the summary for the 50 stories. Similar to the 25 stories, for the Vision Square and Vision Stripe, the total area of application has to be like 6,300 square meters in order to achieve the power output requirement. For ArcLight Active and Lockability Active, the total area has to be increased like 8,316 square meters in order to achieve the total target power output requirement, that is like 540,000 kilowatt hour per year. So this is our different range of products and area of applications and with the typical power output. So as you can see here, Vision Square has the most power output, and next with Stop Ray Active having more power output, and ArcLight Active and Lockability having subsequent power output in the higher range. And Vision Stripe, as you can see here, it is like only like 55 to 60 watt peak per square meter, which is more focused on aesthetics rather than power generation. And we can also help you with the full study of the building from the design stage to the check the feasibility to achieve the requirements on the case by case basis. And we can also support you on all the layouts which is needed to achieve the total power output requirements. Our product also comply with all the IEC certifications, that is IEC 61215 and 61730 requirements, and also comply with the fire safety requirements where like IEC 61730 and EN 13501 and BS 476. We have all those certificates and it can be furnished upon requirement. We also provide a warranty for the glass, that is for standard warranty of 10 years. And we also provide a linear performance warranty, that is for 20 years. And we also comply with the other safety glass requirements for the pendulum testing, that is based on EN 12600, and other durability test like EN 12543, that is for high temperature and high humidity test for the spandrel applications or for any other facade or skylight applications. That ends my presentation. Thank you very much for your time and your attention. If you have any questions, please feel free to ask us, or you can reach me at my email, that is karthik.pillai@agc.com, or in my mobile number at 9728 6004. Thank you very much. Have a good day.